All right, ladies and gentlemen, so we've just talked about the null and alternative hypothesis. So basically, in our list of steps here, we've done this and this A and B, okay? What we're going to do in this video and the preceding videos and the other videos after this, we're going to identify a level of significance, alpha. We're going to check the requirements that we have a normal distribution. I'm going to draw a sketch of a sampling distribution, which is just a bell-shaped curve. And we'll do this in your steps. You can do this if you want to. You don't necessarily have to, but you can. And then we're also going to look at how to calculate the value of a test statistic and what that actually is. I don't know if we'll get to a p-value or not in this video, but if not, we'll get into it in the next. So I'm going to go ahead and flip forward here and go to this right here. And what is the significance level? Well, when we talked about last standard, we talked about confidence intervals, we talked about a confidence level. For instance, a confidence level of, let's say, 95%, okay, confidence level. Well, remember, the significance level, or alpha, is the complement to that. So for a 95% confidence level, when we talk about confidence intervals, then we have a 5% significance level. Okay? Or in other words, alpha, if we don't write it as a percent, is 0.05 for that confidence level. Now, when we did confidence levels, we didn't really talk a lot about alpha. Well, to be honest with you, when we hypothesis test, we talk a lot about alpha, we don't talk a lot about confidence levels. So what a significance level denoted by alpha is the probability of making the mistake of rejecting the null hypothesis when it's true. This is the same alpha introduced in standard 10, where we define the confidence level for a confidence interval to be the probability of 1 minus alpha. Now, significance level, just like confidence levels tend to vary, for confidence intervals tend to vary, the three most common were 99%, 95%, and 90%. Well, the three most common choices for alpha are 0.05, 0.01, and 0.1. With 0.5 being the most common. Okay. Now, generally, we're going to give the level of confidence to you, or excuse me, I'm sorry, the significance level to you in the problem. But if we don't, we're just going to assume then that it's going to be 0.05. As a matter of fact, how do people choose a level of confidence? Well, it just depends on how important it is that you don't accidentally make the mistake of rejecting the null hypothesis when it's true. So what I mean by that is this. Let's say we go back here, and let's say that for this particular example, number 3, the mean, they are actually filling the jars with 32 ounces of peanut butter, but our test data, by just chance variation, happens to say that they are underfilling it. So in other words, that's called an alpha error. We won't talk about that now, but that's what the probability of alpha is, the probability that they're saying by sample data that they're actually underfilling when, in essence, the true population mean is actually 32. They're not underfilling, but our sample data happens to show that it is. Okay, so that's what alpha measures, the probability that you will actually reject the null by your sample data when it's actually true. Now, in the medical field, you can't make those types of mistakes. You can't have, we call those false positives. You can't have a lot of those, so they may use an alpha of 0.01 or even 0.001 because they can't afford to make those mistakes. If you're just talking about an experiment where making that mistake is, you don't want to make it, but it's not essential, then you may look at a 0.05 or a 0.1, okay? But again, the most commonly used is 0.05, and we'll tell you what alpha level to test at. If we don't, you just assume it's 0.05. Okay. Now, this looks like this could be a little bit difficult to understand, but based on your alternative hypothesis and alpha, if your alternative hypothesis is saying that the mean is less than some selected value right here, then we put that alpha on the left. We call that also a rejection region, this red right here that you'll see right in here. We tend to call that a rejection region because if our data falls, our sample statistics fall, or test statistics falls into that area, we reject the null. But for right now, it's called a one-sided test because our alpha, based on, again, our alternative hypothesis, we're seeing if our sample data is less than what we assume the value to be. It's called a one-sided test because the red is on the one side. It's also called a left-tailed test because it's on the left tail. If you have your alternative hypothesis to be greater than a particular value, then that alpha, that amount of alpha, that 0.05, 0.1, or 0.01, tends to be on the right, and it's still a one-sided test, and all of that alpha gets put on the right side, so it's called a right-tail test. Now here's the one that confuses some people. If we just say in our alternative that we want to test if the value is different from what it's hypothesized to be, then we put the alpha on both sides, because that means it could be larger than or smaller than. So we take that alpha and divide it by 2 and put half of alpha on the left, we put half of alpha on the right. This is called a two-sided test or a two-tailed test. Now again, the alternative hypothesis is one side if it states that a parameter is larger than the null hypothesis value or it's smaller than the null hypothesis value. So the first two here are one-sided tests because alpha's on one side. Again, it has to do with the inequality greater than or less than. It's a two-sided test, ladies and gentlemen. If it just says we feel that the sample data would be different from the null hypothesis, okay? Meaning it could be larger or smaller. That's right.